Don regretfully was intending to be here and co-present, so he's not going to make it. I'm going to be presenting some of his work. I've taken some of his slides and just kind of mashed them up with one big PowerPoint. But I'm also going to include a link to Don and Peter's Archiving 2013 presentation, so you can access that online. And also, I don't know what the logistics are, but maybe that'll be available along with this through MCN. So let's see. This talk is about image stitching, primarily for two-dimensional or fairly flat objects. Nothing's really truly flat, but that's what we're talking about, not 3D. 3D is just kind of a whole other can of worms. That's phase 2. This is phase 1. So hi. This is a copper plate engraving. Details from one of our kind of medium small size maps. We have a few really large map collections at Stanford that are kind of high profile, one of which Stanford didn't even own. It was an act of digital philanthropy. A donor said, you can digitize all of my maps. I'm going to sell them to someone else, but make the best copies you possibly can. And so it's really important for us to ensure that we captured all of the information that we needed and made sure that these were useful to the right audience. So we interviewed stakeholders, including the folks from the humanities, art teachers, history teachers, also earth science folks who work in GIS, who have a lot of interest in the scientific data that's kind of wrapped up in these. And then we wanted to be able to present these through SearchWorks, through the brand new discovery and delivery layer at Stanford. So you go through the catalog, you find the map, the item, could be a large photograph that you want, and you're able to kind of pull it up and open it up in a Zoom app. And this is what it looks like before it gets there. So we photograph really large objects in sections and then put them together programmatically, so we stitch them. We produce kind of small tiles. I know some folks will look at this, and I'm gonna kind of talk about the practical aspects and the technique a little bit more so than the science behind it. So we're making smaller tiles. We're making many of them, and then we're putting them together with the rationale is if we give the software exactly what it needs to put together without having to do much, then it should go together pretty well. I recently looked at Wikipedia. I was building up a list of all of the software that we've investigated over the years, and I've been doing this probably since 2005, 2006, from my days at NEDCC. Before Photoshop had decent stitching tools, when stitching was command line, there were tools like Pano tools and Hug-In. PTGUI was kind of a user interface that someone wrote around Pano tools. That worked pretty well. And Wikipedia actually has a really great page. Someone's maintaining it. It's up to date. It has some fantastic matrices and gives you a really good sense of the breadth of tools that are available. I'm sharing some screenshots from some of the more popular ones that have user interfaces. They all sort of work the same way, and they seem to be oriented toward immersives and panoramas, landscape, those types of images, not necessarily flat objects. And they work around, I'm going to call them control points, which is pretty common pretty consistent for most of the software. But you identify elements or features in the two tiles that you want to piece together, and you map them to each other. It's kind of a labor-intensive process, actually. So the software can do some automation, make some best guesses, and then you go in and make minor adjustments. When you have a huge array of files, making these minor adjustments on a file-by-file basis is very time-consuming. So these are meant to be like these epic immersives. They're really fantastic, not necessarily designed for production-oriented work. And then you can really get in and kind of fine-tune the way that some of these programs identify the features that go together. And Photoshop, there are ways of getting under the hood and getting at some of this in Photoshop as well, but it's pretty scary. And I'm not sure of exactly how well it works, and Jeff Chen, who wrote it, isn't either. So we just didn't really investigate that. Even Microsoft every now and again produces a new piece of software that's kind of works well, and their new tool sort of works well. So here's one of our maps stitched together, and then the grandfather, Photoshop. Photoshop made a big improvement between, I think, CS3 and CS4. Behind the stitching application is pattern recognition. And I think that's what they're updating in these software tools. So all of the open source stuff that I showed you before, those haven't really been updated in terms of the technology or the technique. But Photoshop, there was a leap in CS3, from CS3 to CS4 in how Photoshop identifies all of those features and matches them to each other. This is kind of a dramatization of the setup we had at NEDCC. It was kind of a floor-mounted gizmo, a sled that moved in two directions. The camera and lights were stationary, everything flat, a lot of space. You need a lot of space to move in both directions, so you need some clearance under the camera as well. That's why it has that goofy wall mount. And that's pretty much to scale. It was a huge Asaba column that had like a radio tower cables. And that's the Stanford installation. So it's kind of the same thing, slightly different components. And this is in the early stages. So they're building an XY table so they don't have to do the floor work. But for a while, our photographer just was kind of cutting his teeth and learning this, doing the work on the floor. It was going really well. And that basically piece of foam core on a perfectly level, flat plane moves in two directions. And these are kind of the components that you could buy off the shelf pretty much and build your own XY table. We were hiring out some contractors out of San Francisco, really trying to get the survival research folks to build one of these for us, and they were interested. In terms of other components, the lens is really key too. You want to produce squares or tiles that have not zero distortion, but distortion that won't be recorded by the sensor. So you measure the sensor wells, you know how big those sensor wells are, and then you figure out the displacement by looking at the MTFs, and then when you buy a lens that's probably a good match, you kind of refine that a little bit. And you figure out where that image circle starts to express that kind of displacement. And that's how you define your square. So on the left is a 120 millimeter Hasselblad lens, the autofocus. It would have been great if that was if it produced good flat images. Not so much. And on the right was a Schneider 120 APO. And then for the maps themselves, we know exactly what PPI we're going to photograph these at, what spatial resolution. We measure the details that we know we want to record, and then those correspond to the right resolution, the right PPI. Some are photographed at 600 PPI. Unfortunately, some of the really big ones are often 600 PPI. It just works out that way. Many of them, 300 PPI would work fine. We record all of the cartographic detail, the tears. These aren't conservation treatment photos, so we don't need paper fiber necessarily, but that tends to get in there too. And then over the years, Don Williams has developed or kind of added to his portfolio of golden thread products for us to buy. And this is the golden thread dice target or the ISA dice or golden thread target with these little satellite hyperbolic curves, and they also are good for measuring illumination. So we can kind of calibrate to a larger area. And keep in mind, we're photographing squares. We're not photographing the whole map at the same time. We know exactly, it's a 10-inch square, it's a 20-inch square. It's still kind of a tight space, but we really want to make sure that illumination's even and the focus is even, everything's in plane. Talking about workflow, I'm not going to play this whole thing. Some of you may have seen this. This is a training video at Stanford, but I'll play part of it because I think it illustrates well how we use Photoshop. And we just go whole hog. We use the auto settings. We let Photoshop make all of its decisions. And this is pretty much real time. We load the maps, the tiles. We let it do its positioning and blending. And then it produces a layered Photoshop file, which we then go back and QC. So we work from the same file for QC, and we reveal every other tile, and then check those seams between the tiles. So you don't have to check every single tile. You're just checking the transition between the two. And we have staff who get really good at looking at this stuff. Because of the nature of the work, they're really engaged, and they almost never miss anything. I find it hard to trust that they're doing a good job, but I've never found that they've missed anything. So they'll go through and check all of the features and make sure that there aren't any stitching defects, lines that kind of don't match up. And there are examples of these kinds of defects online and also in Don's presentation. And then when they find them, they're just adding another layer and just circling them either for someone else to go and fix, or generally they'll go and fix them themselves. If it's something like hair and it's not interfering with any important information, then they might just edit that out. If it's a stitching defect, like you see in the upper right corner, they're going in and modifying the layer mask. So they're not cloning the image, they're just kind of changing the blending. I think Don calls it scene carving. So just modifying and helping Photoshop a little bit. So some of Don's observations, error detection and prevention and correction. He offers visual cueing features like alignment, like we just saw, where the lines, maps are easy to spot defects in. The lines don't line up. Blending, you might see some sort of a weird transition, especially if the illumination is an issue. And then a couple of other considerations. This is the basic workflow, which I'm not going to talk about, but it's there. Produce the tiles, they get put together, and then they go into the registry as a flattened image. And our throughput for large single, like full frame, P65 plus back, is about 120 to 250 maps in a day, if they're all pretty much the same size, same condition. We have really good metadata and a really good kind of barcoding way of processing this stuff. 4 to 6 tile maps, 45 a day, and that's the honest truth. It takes no time at all to put them together. We have one person performing the QC, and they just bang them out. It's fun for them. I don't think it's fun for me necessarily, but some folks really enjoy that. And Don's thoughts on workflow. I'm not going to read these, but you read them as they emerge. He was finding that other folks at places like Northwestern are working in a very similar fashion. So it's very validating or corroborating. And then this is what Photoshop is essentially doing. It's taking the tiles, finding features that match up, it's overlapping them, and then doing this scene carving. It's picking the path of least resistance, programmatically figuring out where there's the least likely path for an error to occur. And the results. These I'm going to whiz through. I wanted to include some examples of different Photoshop settings. I have a whole suite of files, but they're layered Photoshop files. I can put them up, but you will never be able to download them. Not in your lifetime. I am happy to send a DVD or get them to you somehow if you really want to see them. But suffice it to say, like I said, we use the automatic settings in Photoshop. Some work better than others. Some are more consistent than others. I include this example of this map with kind of the original map and then the stitched version overlaid, and I used difference mode for the layers so that you see any difference between the two. And this is reposition, which is just repositioning the tiles, and it worked perfectly. It doesn't always. Sometimes you see little tiny discrepancies or variation, but much of the time it works really well. So you put in really well-made tiles and you get good stuff out. These you can't see so well. But I whizzed through, they're the other settings, and essentially they all produce kind of a little bit of an offset here and there. And no one can explain why. We had Jeff Chen come to Stanford. We spent a day with him, and he just kind of scratched his head and said, well, keep trying it until you get what you need, because it works differently every time. And this is a close-up with the contrast boosted. So you see that's kind of what those differences look like. And then occasionally you get what our library staff like to call modern art. I tell them they need to get out more often, but it's an epic fail. Sources for variability. Again, you make really well-made tiles to begin with, and they'll go together really well. Make sure that the software is up to date. You're using the latest version, maybe not the latest version, the latest working version. And that your hardware is running the way it should be. And when it is, if you do find at Stanford, if we have at-risk material, we might manually stitch that together. And that works best of all. I mean, that's what, every time I've overlaid a manually stitched map onto, the single shot capture, they've been a perfect match. And manually stitching is just in Photoshop, moving the tiles around. And then blending, and this is from NEDCC. This is from 2005 when we were doing all of this manually. So same approach that Photoshop uses. So we just let Photoshop do that work. Typical issues, occasionally there will be some parallax, something wasn't flat, I missed a tile, so or mixed up tiles. Occasionally operators, put things in the wrong folder. Computer performance is huge. SSD drives. Photoshop does a paging mostly, so you want to have a huge scratch disk on an SSD drive, and that will help determine how fast Photoshop works. And if Photoshop times out on something, if it runs out of resources, it doesn't tell you, it just does a crappy job. So make sure your resources are freed up. And then for really big files, so these are all 8-bit TIFFs. The really big files get upwards of around 3 and 4 gigabytes. And to work with those, we use the big TIFF format, which the preservation folks have a hard time with because it's not a TIFF 6.0. But these end up becoming JPEG 2000s anyway, so if they don't ask, I don't tell them it's a big TIFF. And again, with hardware, Wacom tablets for the folks doing the QC and the touch-up work, speed things up. RAM, 12 gigabytes seems to work fine. You're not really gaining much by adding a lot of RAM because Photoshop probably won't use it. Having a big staging area for the high throughput that you're gonna be enjoying with this process. Having a neutral background, so no black background, no white, because those compete You don't want the background to compete with whatever you're photographing, because Photoshop doesn't care. It's going to look for any of the software. It'll look for contrast. And if it sees a black background with a white speck on it, that looks great to the software. So just give it gray, flat, even background. And then ergonomics. So the folks doing this work, it can be backbreaking work. At Stanford, for our photographer who was working on the floor, I went out and got him the Zafu and Zabuton. I figured these guys sit a lot, and they look pretty comfortable. So that's how our photographer works, and he really loves it. The lights are subdued. It's very therapeutic. And then alternative solutions. So this is a lot of work stitching these together. And the first thing Don asked is, well, why aren't you using some of this other great technology that can be calibrated and do the work that you need to? And some of it would work well, and some of it is just maybe not a good fit for the content. And again, we've got these high ownership systems and the COTS consumer off the shelf. So the high total ownership is the robotic stuff, right? I don't know who's using these, but we've got, what is it? SatScan, Resolution Art, and Google Art, I think, going clockwise from the top. I haven't priced these. The Google technology is not for sale, but and then tactical approaches. Just keep trying. Kind of relax. This isn't in that list, but relax your expectations a little bit. You're not going to produce perfect, but so a 16th century map that's shrunk and expanded for centuries does not have exactly the same cartographic content. Like, the lines aren't exactly as they were 200 years ago. They've moved a little bit. Even the GIS folks were a little bit forgiving. And we're talking about a pixel difference when the stitching shows some variability. So if you can live with that, you can enjoy much higher throughput. And that's why we opt to go with the automatic Photoshop settings. But if it's at risk, no, we'll do it manually, and there's no tolerance. And again, just kind of reiterated in Don's notes here, some more observations. He sees alignment more than merge being an issue. Keep processing edits simple. Again, I can't stress enough how well things work when you just do all of the work in camera, old school. No lens correction, just give Photoshop good stuff. And then further considerations. So Don, right before I came on, said you really should think about mentioning that Harvard University does, they do the tiling, but they won't do the stitching. So they provide the tiles. And if you want to, you can stitch it together. So that's one approach. And then this fellow here, James Walker, who is the behind-the-scenes volunteer, he sent us a paper, which I haven't been able to read critically, but it should be making the rounds. Basically, I think he validates that there's some offset, when you let Photoshop do the stitching, but that it makes decent-looking images. And Don and Peter's paper from archiving. Many of the slides have been just kind of copied in here, but and the acknowledgments. So Don, Peter Burns, Stanford, Northeast Document Conservation Center, Northwestern University, Harvard College, and Jeff Chen at Adobe. And I'm sure there are others. It'd be great to build a community around this, maybe start a wiki or get some community on the listserv for ImageMuse. I think we could build a substantial body of knowledge. But thank you.
Let's answer some questions while we're in the deep of the moment here. We're recording, I believe, so.
Matt, how are you dealing with the folds in the maps?
At NEDCC, we had conservation staff, so they'd hydrate them and flatten them, and we'd see them after a month, and they'd be flat or backed with something. At Stanford, it really depends on the material. There's a vacuum table over at Hoover that they borrow sometimes. Coping glass also sometimes with the guidance of conservation staff. So not putting too much pressure on the material, but with that kind of like a buffer in between. So it's pretty high throughput. So you do what works really well. I think with the glass, the big consideration is how heavy is it, and how easy is it to lift and move around. I mean, you've got a lot of moving stuff, and that's a lot of extra work for the photographer.
And then worrying about reflections.
Oh, well, yeah, the studio is black. We polarize if we need to, but we've got a mask for the camera that's just kind of mounted underneath. So, yeah, it definitely took some prep, but.
Did you look into at all doing putting something on like a 4x5 or 8x10 back and basically using the rear standard shift to move the sensor instead of move the object?
So, phase one has Stanford actually has those sliding backs on all of the cameras. And when we were at NEDCC, Michael Ellis Act was trying to sell us a macro, I forget the name of it, a macro something or other, Sinar, yada yada, for doing that in two directions. So you could do kind of 4 shots that way. But we're limited by the lens, right? The lenses that have a big enough image circle that have low distortion aren't sharp enough. So really that 120, APO 120 macro digitar was the lens to use, and so, yeah, not much leeway.
I know I saw another question.
So once you've got the tiles, I'm worried about the access in terms of what viewer, and then what features do people ask for in the viewer for such large tiled images?
So for the viewers, we have a number of different audiences, one of which is kind of humanities, faculty and students and staff. And they view the maps through online, essentially. The maps are delivered as JP2 through what's called the Zipper app, the Zoom Pan Rotate app that kind of tiles it. It looks like Google Maps, essentially. And this is common. You see it. National Gallery of Art, I think, has a really great website that offers similar functionality. For the GIS folks who want to use this in a geoportal or layer it with some scientific data, they're downloading the full TIFF, which in some cases might take a day for them. Earth sciences don't have really fantastic computing power in the Earth Sciences library, so they're just kind of stuck, or we walk over a DVD. But that's a good question. The really particular use cases require the file, so they just want the TIFF.
Are you saving your individual captures at all, or just the final stitched image for your archives?
To the best of my knowledge, we're not, but we've had to clean off hard drives a few times because, as a photographer who puts in a lot of work, you don't want to let go, and you want to, have that insurance. But, after a year or two of doing this, we've kind of grown comfortable with the idea of letting it go. So the only thing we save is that flattened final TIFF. And for remakes, this is actually a really good question. For remakes, as soon as we've okayed the remake, the previous version is gone. Unless there was something really significant that might help me when I was the image the image quality specialist with like training needs or troubleshooting. But yeah, we just did not want multiple versions of files or even those tiles kicking around.
Wow, definitely not a hoarder.
Uh,
That's pretty,
It's a German heritage. I've just got to clean it all out.
more questions? I'm going to have one question for you, but why don't we switch
Sure.
out tech while we're doing this? My question is non-technical. When you say that Harvard decides to not stitch, to just provide the tiles, what do you mean? That the department itself provides the tiles to whoever it's servicing, or?
Well, that's what Don explained to me, and it makes sense. The Harvard and Stanford tend to be idiosyncratic. You know, they do their own thing, and I think at Harvard they make decisions like that. You know, to offer one thing even though it might be contrary to your expectations, or I don't know. But that's my understanding. Maybe they've changed. I don't know.
Great, let's hear it for him. Okay, next up we've got Michael Nolt, who is working for Ralph Applebaum in New York as the interactive media and content producer, and he has with him Cooper Thomas, who's a senior at Dartmouth College, studying geography, right? So, and I know that we're going to hear a lot of great things about what their relationship is and what they've come up with here, so thanks.
Well, thanks for all coming this afternoon. I know we had some stiff competition with a boy band in the mall atrium. So Cooper and I actually met back at Second Story Interactive in Portland, Oregon, where we were tasked with an interesting map challenge. Somebody had concepted this idea where they wanted to track 300 years of agricultural data and contrast it with 300 years of slave population data. The only problem was the person who concepted it didn't realize that the first 100 years are missing. So that was an interesting introduction to this subject. And we're going to do a little session today on DIY creative cartography. So to give a little historical context to everything, I wanted to start out with a map that many people have found enormously influential over the years. One more try. Okay, so what's the point of that? I wanted to start out with a video game because really it's what this new wave or new generation of cartographers have grown up on. And what is a video game if not a giant, vast, interactive map with a really interesting story behind it? So while our presentation is not about video games, it is about interactivity and narrative. So rather than focusing on what I would call reference maps or location-based maps that are telling you how to get from point A to point B, what we want to talk about is actually much more relevant for the museum and the educational sector, which is this combination of geography, narrative, and interactivity. And so through the course of this presentation, we'll give you a little bit about how those are all interrelated and how you might take advantage of some really interesting online opportunities at your institution. So we want to start by making this claim. We are living in an era of unprecedented cartographic creativity. So let me give you a little bit more evidence to back up that statement. That's a quote by me. I didn't tell you it was by me because I thought you might take it more seriously if I just put some quotes around it. So we're seeing a rapid explosion in multiple sectors involved with cartography and geography. The first being publications, maps, blogs, conferences, etc. I think it was about 3 years ago I was able to follow every single map blog out there. Now I can't keep track of them all, which is very frustrating to me. There has been a proliferation of books out there, which has been deleterious to my bank account. Second sector I want to talk about is tools and software. So just over the past 4 or 5 years, we are seeing an explosion of tools that you can use that can really take you from the concept of your map and the data all the way through the publication process. So we're going to get into what some of those tools are a little bit later in this process, but this is a very recent trend. The other thing I should mention about that is that almost all of this software from the past few years is open source, which will be a recurring theme here. And then the last bit, which is probably the most important bit, is we have seen a vast explosion of open source data. So let me give you a little video to demonstrate that idea. OSM is OpenStreetMaps. It is an open source project started in 2004. And this map shows edits to the OpenStreetMap data starting in 2007 and continuing over the next 5 years. So OpenStreetMaps, compared to something like the Google Maps or Google Maps API, is an open source platform where anybody can go in and edit it, add data, do whatever they want with it. So what you're seeing here is every white flash is an addition of data or a revision of data. Every large chunk of color is an importation of data, so they've been able to access large plots of data and put it into their system. So of note here is how easy it is through OpenStreetMaps to make very rapid revisions to street map data. And a great example of this, there's a story in the Atlantic Monthly that just came out a few weeks ago about how during the recent hurricane in the Philippines, people were able to very rapidly go to OpenStreetMaps, change the infrastructure, and then reflect that almost immediately through OpenStreetMaps. Meanwhile, Google Maps or any other sort of proprietary software wasn't able to keep up. So it's great for the world community. So the structure of our presentation is kind of a left brain, right brain structure. Don't look too closely. I don't know if I've got the ones mapped to the right side of the brain. But we're going to start out with giving you a little bit of an explanation of, we're seeing this recent trend, so what are the events that have led us to this point? And then the second half of the presentation, which Cooper's going to do, will be a little bit of a tutorial that will take you through the steps from having a chunk of data to actually telling a story about it and then publishing it online. So let's start out with the why. And I want to provide an ever so brief history, and apologies to anybody who is a map historian in the audience, because I'm going to condense about 2 millennia of map history in about 90 seconds. So let me start out with this quote from an author named J.B. Harley, who famously described geography as the science of princes. I think this is a perfect quote to sum up the first 2 millennia of map making and map history. And this is a quote that comes from a book called The Hidden Agenda of Cartography, where he makes an argument that cartography through the ages has been used almost like an imperial weapon. So the point is, countries, governments used it as proprietary intelligence to do things like create trade routes or to map out military intelligence. But the point is, they kept all of that information locked away. So you couldn't just go to a library and find it. You couldn't go to an open university and get at that information. It was kept really as a weapon. Same thing goes for tools. They were scarce. Publication-wise, people didn't have the rapid tools that we have now. Publication tools were either very heavy or unwieldy. Communication was not what we have today. So let me cut to this timeline, and we'll post this so you can look at it a little bit more closely on a slide share through the video. But things start to get interesting around the late 1790s with the introduction of the US Census. Not going to go into this too much, but starting with 1790 and going through early and mid 1800s, the United States and other countries started making data a little bit more available. So you start to see municipal agencies unleashing data related to things like crime, health, weather. So the mid-1800s was kind of a halcyon area for cartography. And there's a great book called Mapping the Nation that really goes into depth of what was going on in the mid-1800s. So let's fast forward to what we're calling the open source era. This has really been going on for, say, the past 10 years, where suddenly in the mid-aughts, everybody has handheld GPS devices where they can contribute to open source projects like OpenStreetMaps from the palm of their hand. We also start to see the introduction of the internet where anybody can publish anything from anywhere. And we're going to get into some of what those exact software tools are. But starting in 2011, we see the introduction of Mapbox, which is more or less the WordPress or the Tumblr of map publications. And then finally, open source data. So OpenStreetMaps is just one example. There has been a proliferation online of all sorts of data that anybody in this room can have access to. Okay, so that's the why. Let's switch brains and get into the how. So when people ask me how do you start out the process of map making, it usually starts with concepting. So I'd ask them, okay, well, what is the story that you're trying to tell? And having a good concept, good story, is really going to be the foundation of any good map. So I tried to distill all the different styles of storytelling into really just a few examples. Of course, there's many more than this, and you can kind of mash these up. But I wanted to take you through some interesting examples to give you an idea of different types of storytelling maps. The thing about really knowing what the narrative is if you know what your story is, then you can communicate that to a scientist or a curator or whoever you happen to be working with, because that's going to give you your framework. And then you can start pulling out inspiration. And it's just a shortcut to really communicate what you're trying to get at. So let's start out with what I would call a journey map. This is one of my favorite online maps. This was published in 2007 by the New York Times graphic department. And it shows one man's journey up and down Mount Kilimanjaro. And the fascinating thing about this map is that typically you would see this on a flat raster 2D map. But here you're seeing it much more in scale. So you see how difficult it was to actually climb this mountain. And you also start seeing some layering of information. So you see the heart rate, oxygenation level, and then as you go along, you get this multimedia that's added to the program. So a different type of journey map. This is what I would call a vignette or an illustrated map. This is a set of postcards that was given out by a resort in Germany. And the intent was, as people take river trips down the Rhine, they have this little map that they unfold, and it starts to show them all of these illustrations of tourist spots along the river. So starting in Cologne and going south, this is kind of an amazing map. And I couldn't put it on a single slide, so I made it into a movie because it keeps going and going and going. But I like this one because conceptually, you could see how this could transform very nicely into an interactive. So you could be scrolling on an iPad and picking out hotspots, and that is kind of a prototype for that type of experience. So one of the most popular types is what I would call a comparative map. In the 1800s, there was this trend where suddenly everybody felt like they knew the lengths of all the rivers in the world and all of the mountains in the world. So this is almost an early cartographic meme. There's dozens of maps like this. And this is doing essentially that. It's putting all the known lengths of many rivers in the world and comparing them to all of the mountains. I kind of like imagining the creative brief on this one, where some creative director sits down a poor graphic designer. It's like, all right, I want you to take every river in the world and put them next to each other. The guy's like, oh, okay. And then I want you to take every mountain in the world and put them next to each other. Anyways, these are lovely, and I think you could see how a school child or anybody could really get a great grasp of a vast world of geography in a single portrait. You can see some ultra high-res versions of this through different libraries, but there's also a great blog called the Big Map blog. So this is one that's not mentioned very often, but if you're starting to fall asleep, not picking anybody out of the audience, but this is a point to kind of, yeah. So this might wake some people up. You might recognize this. So this to me is super interesting because what it's doing is taking a fictional idea, giving it a geographical context, and then communicating a sense of place. This is something that you can't do in the show itself. So if you're not familiar with the show, this is for Game of Thrones. And what it does is it really feeds into the concept of the show itself through the design. So it's a really simple idea that you could use. Movies use it all the time, but I think it'd be great if we could use it in museums a little bit more frequently. So that's my gratuitous pop culture reference. Okay, very frequently used is what I would call the pattern map. So in the 1850s, there was a doctor in London named John Snow who started taking statistical information related to fatalities and cholera and put that up against street maps in London. And what he found through this statistical analysis was that all of the fatalities were grouped in one certain area. So by doing that, he found that he made a correlation between a tainted water source in this grouping of fatalities. This map is not from London. This is from an area in Boston where they are doing the same exact thing. So one of the most common types that you see, and one that you can use very easily in museums, is what I would call change over time. This is a map that was created by NASA based on Landsat data. It's a beautiful map. This is false color. This is all based on data. And it shows a glacier in Alaska called the Columbia Glacier that has receded over the past 12 years or so by almost 20 kilometers. This dramatically communicates a very simple idea with no text. So this is the last example that I wanted to show you, and it's a mashup of two different styles. It's a pattern map and a change over time map. And this is related to rentals in San Francisco. So if anybody's from San Francisco, you may have heard of what's called the Ellis Act. And this is an act that allows landlords to suddenly close up shop or close out their business, kick everybody out of their apartments, and then release them at higher rates. So the purpose of this map is more political than anything. And let's take a look at it. So this is an interactive map. It starts to show an accumulation of people over time that have been kicked out of their apartments because of this act. And this map itself was made by a developer, in part by a developer at the Oakland Museum of California. So what we're seeing right now is we're right in the middle of the dot-com boom. So you see everybody's got a ton of money and sleazy landlords are taking advantage of this loophole to kick people out. But it's interesting to compare it to the chronology of the time because right around now you start to see it slow down a little bit because this is the dot-com bust. It's happening right after 9/11. Okay. So we've addressed the why and the how, and we're going to turn over now to the cooking portion of the program.
Thanks, Michael. I was sort of hoping you were going to play the Game of Thrones song muted because I'm going to have it stuck in my head for the rest of the day. I also think you noticed the Jon Snow reference there. So for the next few minutes, I'm just going to walk through, I guess it'll be more of a trot, through a sample interactive map workflow. Basically going from a concept to a finished map published online. And I'm probably going to gloss over some of the steps in the interest of time. But bear in mind that the purpose of this demonstration isn't so much to provide a comprehensive step-by-step tutorial as it is just to give you a general sense for the ease with which you can build a map today using open source data and software, and especially with very little computer programming experience. And so Michael and I like to use this recipe analogy, although come to think of it, I don't know if I'd really want to eat whatever that is. It's like some sort of dough. But as you can see, there are really three things that you need to produce a map. You need a concept or a story that you're trying to tell, which is what Michael went over earlier. You need your source data to undergird that entire story. And of course, you need a mapping platform, which we'll use to visualize and eventually publish your finalized map. And so for this particular demonstration, we are going to be looking at the urban development of Chicago over the past century and a half or so. And I've chosen Chicago because, of course, the city's storied history as a industrial center turned, suburbanized sprawl turned global financial center is sure to sort of show up some really interesting patterns, spatial patterns over time. I think we also probably have some Chicagoans in the crowd here, so you might find this particularly interesting. And the second ingredient, again, is the spatial data. We're going to be using data from the Chicago Data Portal. They have a great online resource which allows you to download free geospatial data at the click of a button. It's really helpful and useful. I encourage you all to go in there and poke around if you want to see what's out there. And without further ado, let's just jump right in. Well, actually, first I want to talk about the mapping platforms because that's sort of a critical component. We're first going to be using QGIS, which is a geographical information system. It's free and open source, and it essentially allows users to quickly and intuitively edit and visualize and analyze geospatial data. Then we're also going to be using TileMill, which is an open source map design suite, which essentially allows users to take that geospatial data, make it look pretty, and prepare it for use on the web. And then lastly, we're going to be using mapbox.com, which, as Michael said earlier, is basically the most common platform for actually publishing maps. And mapbox.com actually, they developed TileMill, and so there's some great integration going on there. Mapbox is sort of a freemium setup, and so you can use either a free account or purchase a monthly plan. But keeping with our sort of free theme for this presentation, we'll be using a free plan. So without further ado, let's jump right in. And so let's get out of Keynote here. And the first step is to download your data. So I'm just going to navigate over here to the Chicago Data Portal, and I've already brought it up here. You can see all the building footprints. And I'm just going to download the data as a shapefile, which is more or less the most common geospatial data format today. Shapefiles store not only the geometric information, the points, lines, polygons, or what have you, but they also store the attribute information. And for our particular example, we're going to be looking at the date at which the buildings were built in Chicago. And so I've already downloaded this file and loaded it into QGIS just to save us some time. And so when you open it in QGIS, this is what you're going to see. On the left, you can see your layers panel, and here you can see basically what we saw on the website. Although the difference is that now we can open the attribute table and actually see some more information about these buildings. So if I open that up, I've already opened it up because, as you can see at the top, there are about 820,000 buildings in the original file. And if I were to do that on my poor 4-year-old MacBook, I think it would take about 10 minutes and probably overheat. So I've already done that in advance. And you can see all these are all the buildings here. And if we scroll from the left and right, you can see all these different fields that have been stored. And so for us, a lot of these aren't really relevant. We're only really looking at the year the building was built, which you can see here. And unfortunately, you can see that a lot of these buildings don't actually have construction dates. Instead, they've just been stored as 0. So before we actually go ahead and visualize this data, we're going to sort of filter out some of these buildings that aren't necessary. And to do that, we can just do a simple query. You basically just write a quick expression that filters out all the information that we're eventually going to want to delete. And so in this case, we will do year built equals 0. Oops. And I'm also going to get rid of all buildings smaller than 200 square feet. And that might seem like a pretty big omission, but at the scale of Chicago that we're going to be looking at, it won't really be noticeable, and it'll certainly speed up just the processing. And so let's do shape area is less than 200. And if I were to go ahead and select this now, again, it would probably take like 10 minutes for it to actually go through and identify all the ones. And so I've gone ahead and done that already. So I'm going to close out of this. And that cleaned up layer is what you see below here. And this is also probably going to take a minute to do. Now's a good time for a geography joke, if any of you have them. I don't know. Why is the west latitude in need of cheering up? Because it is always negative. Oh, goodness gracious, all right, there. Spared. And you can't really see these here, but I've already gone ahead and applied a basic color ramp to our cleaned up file. And if we go into the attribute table for this one, you can see it's going to load all the features. And you can see I've gotten rid of a bunch of the different fields here. It makes it a lot easier to look at. And there are only about 450 individual buildings now, which means it'll be a lot quicker as we sort of go through the visualization and export process. Again, you can see here that I've added a simple color ramp to the buildings. If we go into the layer properties here, if it wants to cooperate. Uh-oh. There we go. So you can see here the buildings have been colored based on the year in which they were built, and I've basically broken it into 6 different classes based on sort of quarter century marks. And as you can see up here, this is the attribute that is being used to stylize those buildings. Okay, now that our data is all prepared, you'd save this out as a new file. I've already done that, so we can go ahead and move into TileMill. And TileMill is what we're going to use to actually prepare this vector data and convert it into raster tiles, which we'll then upload to mapbox.com for viewing. And as you can see here, I've already added the layer in, which is just as simple as directing TileMill to the file path. But we don't actually see anything in our window here, and that's because we haven't styled the data yet. And TileMill uses Carto CSS, which is a simple programming language. It's a derivative of cascading style sheets, which is a pretty common markup language for web development. And if you don't have much programming experience, it can be a little bit daunting, but once you get the hang of it, it's super intuitive and super easy. So basically, we just tell it what layer we want to do or stylize, and then we tell it how we want to stylize those layers. And so in this case, we're looking at the buildings layer. And again, we are going to color it based on the year built attribute. And so we just go ahead and tell it year built and greater than or equal to 2000. And then we tell it what we want it to look like. Oh, yeah, that probably wouldn't work too well. And this little area right in here is where we're going to put our color code. And you could just go ahead and enter some numbers. TileMill uses hex codes or hexadecimal color codes, which are basically 6-digit alphanumeric codes for each color. So you could just enter in like some numbers. Oops, there we go. And then once it's in there, you can go in there and mess around with it and save it as you want. But what I'm going to do instead is I'm actually going to use colorbrewer.com, which is an online web application that's designed especially for generating color ramps for use in maps. And this is a super intuitive interface as well. You basically just select the number of classes you want to visualize, in our case 6. You choose the kind of color ramp you want to use. We'll use diverging. And you can choose your color ramp and hex codes. And then it's just a matter, well, I guess I want to copy this a few more times. I'd copy this 4 more times to get all 6 classes. And then it just becomes a matter of copying and pasting your hex codes, which are right here, into your style sheet over here. And I've already gone ahead and done that to spare you the pain of watching me copy and paste, or try and copy and paste. And so I've got that going on over here in a different style sheet. And I've just commented it out so it wouldn't show up earlier. And you can actually see along the bottom here, as soon as you enter in the colors, TileMill will recognize them and will go ahead and let you edit them down here. And I've tweaked the color ramp a little bit, and that's because I'm eventually going to put this layer atop a black base map. And so we really want them to pop out a little bit, and so I've made them a little bit brighter. And then as soon as you go ahead and hit save, it's going to render whatever information you've entered. And this can take a second as well. Keep in mind that we're rendering about 450,000 different buildings. Yeah. Why do paper maps always lose to interactive maps in poker? Because they always fold. Okay, good. This is up now.
Video recorded for all posterity.
Just don't add my name to this presentation. I don't know, I want to get a job. And so if we want to try and see what it looks like on a black background, we can just simply map background color, and we'll enter 000, which is the hex code for black. And if we render this again, you can see that the color black has been added down here instantly. I'm really out of jokes now, so I don't know. There we go. Okay, so this looks pretty good right now. You can see just the general patterns in the evolution of the city here. We'll get into more of that in a minute. But we're still missing a few key elements. We need a legend, and we'd also like to put in some tooltips, which are just little bits of information that'll pop up in the corner whenever you hover over a particular building. And so I'm going to go ahead and create the legend here, and you can either create an image in some sort of external graphics package like Illustrator, or if you're going fully open source, you could use Inkscape, and then just link it in here. You can also generate a legend using HTML, which is what I've opted for here. And I've actually got that code stored in another style sheet here, so I'm just going to copy and paste that in. And if this looks pretty daunting, that's okay. I didn't actually write this all myself. I just went ahead and copied and pasted this from the TileMill documentation online. If you go to the Mapbox website, they have great resources here, and I just sort of tweaked the color codes and the names of the different classes to reflect our data. And this is also a good point to talk about what I think is one of the main advantages of open source software over commercial alternatives, and that's the user community and the documentation. I've found that if I ever encounter a problem or have a question or just need some inspiration, if I go online and poke around the message boards, maybe pose a question of my own, or just look at the developer's documentation, I can usually get an answer within an hour or so, and that's not always the case when you're dealing with commercial tech support, as I've also found out the hard way. And so if we go back into TileMill, you can see I've added the different classes in here and applied the colors that we're using. And so if we hit save now, you can see that the legend is in place now. And the next thing that I'm going to do is add tooltips. And that's even easier than the legend. You basically point TileMill to the layer that you'd like to add tooltips to. You add a little bit of text, and we want to show the year that the buildings were constructed. And then you just copy and paste in the field that you want TileMill to draw information from. And I'm also going to add a strong tag in here just to make it really stand out. The tooltips and the legend, again, support full HTML and CSS, so if you want to get really creative, you could change the formatting, you could link to external images, you could even link to Google Charts. There's a lot of stuff you can do. It's a very robust platform. And so now when we hit save, it's going to re-render. Hold your breath, the suspense. Alrighty. So there you can see it. And if we zoom in a little bit, it sometimes takes the tooltips a few seconds to initialize. I'm not entirely sure why. Well, perhaps I should not have zoomed in there because now it's gonna, oh, there we go. And so let's just give the tooltips a second. We can do some fun panning around. Great, there we go. So now you can see that whenever I hover over a building, it's gonna tell me the year in which it was built. So now we're ready to go ahead and process our map and export it as map tiles. And this is sort of the inverse of what you were talking about earlier. We're basically taking a huge image and breaking it down into 256 pixel by 256 pixel squares. And the reason we do this is because once we put it on the web, if you have users that are scrolling around and zooming in and out, you don't want to have to render one giant million pixel large image. It's a lot easier if you can do it in sort of a modular function and only render the tiles that you're actually looking at. So we'd go into the export settings here, MB tiles. This looks like it's going to take a minute again. And so It's really important that when you go to export your MB tiles file, you set your zoom levels to a level that's appropriate for your spatial extent or whatever you're looking at, because I guess the zoom levels, every zoom level you go up, you have to render 4 times as many tiles. And so you can very quickly go from, just a dozen or a couple hundred tiles to thousands, and of course these take up a lot of space. I think if you rendered like this all the way up to zoom level 22, which is about as close as you can go, it would be about 300 gigs, which would seriously kill this computer.
So one thing of note there is just that that's something that you can kind of figure out when you're doing your concepting, because you don't need every single zoom level if you're building something for a museum. Google needs that because it's really more about location-based things, but this is more about storytelling. So you can do something that really just has 2 or 3 different levels to it.
Right. And that's especially valuable in our case because we're really looking at general patterns in Chicago. We don't need to zoom in and see individual building footprints so much as we just want to see the general distribution of buildings and when they were built. This is obviously not cooperating. Fortunately, I've gone ahead and exported the file already. And so now we can navigate over to mapbox.com, which is where we're going to host these newly processed map tiles. I'm going to go ahead and log in here. Oh boy. If any of you want to sponsor a new computer, that would be awesome. This is really on its, really on its last legs now. Creative cartography.
So if you haven't heard of Mapbox, it's well worth looking up. It's a great tool. It's all open source. It's only been around for 2 years. An emerging community, but kind of a perfect tool for museums, universities. More and more platforms are using it. Foursquare uses it. Washington Post is using it. And especially for storytelling purposes, it's a very versatile bit of software.
Yeah, and one of the cool things about Mapbox is that it actually uses OpenStreetMap data for its base layers. And OpenStreetMap is awesome because that data is constantly being updated dynamically on the go, whereas Google, I don't know how frequently it updates its data, but occasionally you can zoom in really close and see some discrepancies. And so I think Mapbox is also entirely open source if you want to dig in. And so we're going to navigate over to our data, well, hopefully. All right, and I've already gone ahead and uploaded this because it can take a few minutes to process. But now we're actually going to go ahead and frame our newly processed map tiles against a simple base map just to provide some geographic context. And so we can create a new map project based on this data layer, and that'll bring us into the interactive map design studio online. And since our tiles are really bright, we want to use a super subdued background. We can choose different base layers here. If you wanted to use satellite, you could. I like the terrain one. And of course, you can't see our buildings here, again, because they're so bright. And so I'm just going to go in here. Let's make this really, really dark here. Let's try that. That looks better. Okay, and those labels are also a little bit too bright, and so I'm just going to reduce the alpha level of those to make them a little bit more transparent. Okay, that looks pretty good. As you can see, this is a super easy way to make an attractive map or a really ugly map if that's what you're after. And so then you just hit save and share, and this is going to generate a new URL which we can just plug into a new tab, and then we can explore our new map. Nope. Tile Mills probably finally decided to cooperate in the background. Why didn't the map have any meridians? Because it was a map of a parallel universe. Okay, so here's our final map. So let's go ahead and explore this a little bit. As you can see, all the oldest buildings in Chicago are sort of in this inner ring here. All the blue buildings, again, were built before 1900. And because this has all been processed from vector data into raster tiles. It's a lot quicker to navigate and to load. These are all being served in real time from Mapbox. So you can see all these old buildings here, but as you move away from the city center, you start to see newer and newer developments and newer housing developments in particular, which are indicative of the phenomena of white flight and suburbanization throughout the mid-20th century. And it's pretty fun to explore this. You can sort of pan around, see some of the really quintessential suburban housing developments like this. These were all built in the mid-50s. You can also see some iconic landmarks like I think this is Soldier Field. I don't know why it says it was built in 2005. I thought it was super, super old, but that has to do with the data. That's on the city of Chicago, not me. So, rebuilt? Somewhat. There you go.
So our dirty little secret is that neither of us have that much knowledge of Chicago. But you could see at this point where you could partner with a Chicago-based urban planner to tell some really fantastic stories about what's going on here. So this is kind of the point where you would want to partner with a subject matter expert. Because we're doing things like, where's Oprah Winfrey's apartment?
We couldn't find it. It is cool though if you look at the Loop and like the immediate surroundings of the downtown area, you can see how many newer buildings there are, which again is indicative of Chicago's reemergence as a global financial center over the past 20 years or so. And so that just gives you sort of a whirlwind look at just how easy it is to produce a map, to go from concept to completion in a matter of minutes. I apologize, I was going super fast there and jumping over some steps. But again, the purpose was just to show you that you can do this with virtually no experience. It's a ton of fun. We encourage you to go out there, poke around with the data online. There are a ton of great resources you can use. A lot of different blogs and message boards you can look at for inspiration or guidance. So yeah, that's what we have for you. Encourage you to get out there, get your toes wet in the mapping world, and have fun with it.
We had one last slide. Last slide. Wait for it.
Woo!
DIY mapping, love it. I don't know about you guys, but I would love to see the next MCN, maybe a workshop where we all get to get our hands dirty with some of our own stories. What do you say? Yep. So questions for these guys? Okay, Andy.
Hey, thanks a lot, guys. I'm wondering how do these tools translate to indoor mapping? What's the state of that kind of work?
Indoor mapping?
Yeah.
Well, as long as your data is geo-referenced in that it's sort of spatially aware, you could really map anything. Of course, it would be more difficult to composite your data with these Mapbox-based maps because they obviously don't show indoor mapping. But if you wanted to, say, create a floor plan or something, it would be super easy to implement with your own data. And what I showed you, creating a map through TileMill, is really the tip of the iceberg. If you have any programming experience, especially with JavaScript, there are dozens of amazing JavaScript mapping libraries out there. Mapbox actually has their own. And with just a few dozen lines of code, you can create your own map that doesn't need to be run through the Mapbox website. And so, yeah, I encourage you to sort of explore a little bit and see what is out there. And I'm sure some other people have looked at that before.
Cool.
So one super important point I just wanted to make about data and concepting is before you commit to making any sort of map, I highly recommend making sure that the data actually exists. So another thing that you don't see is before we came to the conclusion of doing a Chicago-based map, we went through about 5 different concepts where I was tasking poor Cooper with all of these ideas for data that does not exist. So before you commit to any of your colleagues or partners, make sure that that is readily accessible and cleaned up. Otherwise, you're going to spend 90% of your time actually making that data workable.
Hard to work with imaginary data.
So if you wanted to, say, export data from your collections management system, and say, you know that your artists, were from a certain, like a town. Would you have to go through manually and like put in GPS coordinates for, say, a city? Or could you just kind of take that spreadsheet and use it to visualize the data?
Sure. So this is a process called geocoding. It used to be really difficult, and it's basically what things like Google Maps or MapQuest use to take an address, convert it to lat-long coordinates, and then sort of link them together. And today there are free scripts that you can download that'll do it automatically for you through like Google Drive, or you could also download them to your own machine and run them locally. So this is a pretty easy process as long as you have just some sort of geographic information, whether it's a city or as specific as an address. It is possible and it's super easy to do.
Is there an SDK for Mapbox for your implementation on Android and iOS?
There is.
Oh, very good. That answers that question. Way to go.
You guys have very clear set answers.
Yeah.
Great. More questions?
Josh has got one.
Wait, sorry. Okay.
You may have said this, and I'm sorry if I missed it, but do any of those solutions have any sort of time-based component to them as well? So, for example, tracking provenance of an artwork?
Yeah, it would be difficult to implement in TileMill itself. TileMill doesn't offer any sort of animation functionality or sort of multi-layer switching, but you can implement that through the Mapbox.js library, and most other JavaScript-based mapping libraries do offer such functionality. They're super robust, and you can sort of wield them however you want and make what you want to make out of them.
So our first idea was to do something with Chicago where you could kind of scrub through Chicago over time to do this sort of change over time style map. And for the purposes of this presentation, we needed to make it more of a flat map or something that's more static in time. But that's kind of the next step in, if this is a 101 presentation, the JavaScript implementation would be more of a 201 or 301. But that Ellis Act map that we showed uses 3 different JavaScript libraries that are all open source to do that style of interactivity. And that would be a good place to start, is looking at the engines that they use. So
I don't think that particular map used the Mapbox JavaScript library.
I think it was Leaflet, CartoDB, and it's directly on that map itself, yeah.
It sounds like if a lot of this sounds like a lot of different names, it would just take a little bit of poking around on some of the blogs to re-put back our mental map of what happened today.
Mm-hmm. And we're also going to post our slides to SlideShare. We have some other screen caps that just give you a basic idea of the different stages. And I think those might actually be more informative than me just sort of flying through a lot of these processes.
This is more of a comment, but I studied urban planning in 2006 through 8, and the thing that I hated most was GIS work, not because of what it could be, but because of the process. It was so clunky and so annoying, and I just avoided it like the plague.
Right.
And it's like really exciting to see this. This is really, really cool stuff.
Yeah, I don't know who out there has worked with ArcGIS or programs like this, but previously very, very expensive, unwieldy, and you had to go to school to learn this type of stuff.
You also
And-
need various proprietary software that costs
Right.
so much.
And it's an annual membership. So back to our original point that this is really an unprecedented time in map making, and it's really exciting to see what will come out. And so I encourage museums to really kind of take the reins and see what they can do with it.
Yeah, and just another comment about that. One of the really cool things about QGIS is that it has a super modular setup. It's based more or less on different plugins. So there's this core framework and user interface, and you can add in however many plugins you want to offer different functionalities, or you can just strip it down to a bare bones geospatial data visualization program. And so sort of the threshold to entry and understanding what's actually going on is pretty low, especially compared to programs like Mapbox, or sorry, like ArcGIS.
Thanks everybody for your attention through this. Thanks for staying.
Anything else? Well, before we give one last hand to all of our panelists, I just want to point out we have one last thing of the day. After there'll be a coffee break right after this. Closing plenary, we're going to have just wrap some things up with remarks and then talk a little bit about if you've seen the layer of chaos and why it matters, why we're doing it. And but it will be very quick and informal for everyone to kind of also check that out, check out the projection mapping, and maybe touch a wire or so, and say your last goodbyes before heading to the bar. So thanks everybody.
Thank you.